So generative AI is a type of artificial intelligence, type of artificial intelligence that creates new content based on what it has learnt from existing content.
The process of learning from existing content is called training and results in the creation of a statistical model. When given a prompt, GenAI uses a statistical model to predict what an expected response might be, and this generates new content. It learns the underlying structure of the data and can then generate new samples that are similar to the data it was trained on. Like I mentioned earlier, a generative language model can take what it has learned from the examples it's been shown and create something entirely new based on that information. That's why we use the word generative. But large language models, which generate novel combinations of text in the form of natural-sounding language, are only one type of generative AI. A generative image model takes an image as input and can output text, another image, or video. For example, under the output text, you can get visual question and answering, while under output image, an image completion is generated, and under output video, animation is generated. A generative language model takes text as input and can output more text, an image, audio, or decisions. For example, under the output text, question and answering is generated, and under output image, a video is generated. I mentioned that generative language models learn about patterns in language through training data. Check out this example. Based on things learned from its training data, it offers predictions of how to complete this sentence. I'm making a sandwich with peanut butter and jelly. Pretty simple, right? So, given some text, it can predict what comes next. Thus, generative language models are pattern matching systems. They learn about patterns based on the data that you provide. Here is the same example using Gemini, which is trained on a massive amount of text data and is able to communicate and generate human-like text in response to a wide range of prompts and questions. See how detailed the response can be? Here is another example that's just a little more complicated than peanut butter and jelly sandwiches. The meaning of life is, and even with a more ambiguous question, Gemini gives you a contextual answer and then shows the highest probability response. The power of generative AI comes from the use of transformers. Transformers produced the 2018 revolution in natural language processing. At a high level, a transformer model consists of an encoder and a decoder. The encoder encodes the input sequence and passes it to the decoder, which learns how to decode the representations for a relevant task. Sometimes transformers run into issues though. Hallucinations are words or phrases that are generated by the model that are often nonsensical or grammatically incorrect. See, not great. Hallucinations can be caused by a number of factors, like when the model is not trained on enough data, is trained on noisy or dirty data, is not given enough context, or is not given enough constraints. Hallucinations can be a problem for transformers because they can make the output text difficult to understand. They can also make the model more likely to generate incorrect or misleading information. So put simply, hallucinations are bad. Let's pivot slightly and talk about prompts. A prompt is a short piece of text that is given to a large language model, or LLM, as input, and it can be used to control the output of the model in a variety of ways. Prompt design is the process of creating a prompt that will generate the desired output from an LLM. Like I mentioned earlier, generative AI depends a lot on the training data that you have fed into it. It analyzes the patterns and structures of the input data and thus learns. But with access to a browser-based prompt, you, the user, can generate your own content. So, let's talk a little bit about the model types available to us when text is our input and how they can be helpful in solving problems, like never being able to understand my friends when they talk about soccer. The first is text-to-text. Text-to-text models take natural language input and produce text output. These models are trained to learn the mapping between a pair of text, for example, translating from one language to others. Next, we have text-to-image. Text-to-image models are trained on a large set of images, each captioned with a short text description. Diffusion is one method used to achieve this. There's also text-to-video and text-to-3D. Text-to-video models aim to generate a video representation from text input. The input text can be anything from a single sentence to a full script, and the output is a video that corresponds to the input text. Similarly, text-to-3D models generate three-dimensional objects that correspond to a user's text description for use in games or other 3D worlds. And finally, there's text-to-task. Text-to-task models are trained to perform a defined task or action based on text input. This task can be a wide range of actions, such as answering a question, performing a search, making a prediction, or taking some sort of action. For example, a text-to-text model could be trained to navigate a web user interface or make changes to a doc through a graphical user interface. See, with these models, I can actually understand what my friends are talking about when the game is on. Another model that's larger than those I mentioned is a foundation model, which is a large AI model pre-trained on a vast quantity of data designed to be adapted or fine-tuned to a wide range of downstream tasks, such as sentiment analysis, image captioning, and object recognition. Foundation models have the potential to revolutionize many industries, including healthcare, finance, and customer service. They can even be used to detect fraud and provide personalized customer support. If you're looking for foundation models, Vertex AI offers a model garden that includes foundation models. The language foundation models include chat, text, and code. The vision foundation models include Stable Diffusion, which have been shown to be effective at generating high-quality images from text descriptions. Let's say you have a use case where you need to gather sentiments about how your customers feel about your product or service. You can use the classification task sentiment analysis task model. Same for vision task. If you need to perform occupancy analytics, there is a task-specific model for your use case. So those are some examples of foundation models we can use, but can GenAI help with code for your apps? Absolutely. Shown here are generative AI applications. You can see there's quite a lot. Let's look at an example of code generation shown in the second block under the code at the top. In this example, I've input a code file conversion problem, converting from Python to JSON. I use Gemini and insert into the prompt box, I have a pandas data frame with two columns, one with a file name and one with the hour in which it is generated. I'm trying to convert it into a JSON file in the format shown on screen. Gemini returns the steps I need to do this. And here, my output is in a JSON format. Pretty cool, huh? Well, get ready, it gets even better. I happen to be using Google's free browser-based Jupyter Notebook and can simply export the Python code to Google's Colab. So to summarize, Gemini code generation can help you debug your lines of source code, explain your code to you line by line, craft SQL queries for your database, translate code from one language to another, and generate documentation and tutorials for source code. I'm going to tell you about 3 other ways Google Cloud can help you get more out of generative AI. The first is Vertex AI Studio. Vertex AI Studio lets you quickly explore and customize generative AI models that you can leverage in your applications on Google Cloud. Vertex AI Studio helps developers create and deploy generative AI models by providing a variety of tools and resources that make it easy to get started. For example, there is a library of pre-trained models, tool for fine-tuning models, tool for deploying models to production, and community forum for developers to share ideas and collaborate. Next, we have Vertex AI, which is particularly helpful for all of you who don't have much coding experience. You can build generative AI search and conversations for customers and employees with Vertex AI Agent Builder, formerly Vertex AI Search and Conversation. Build with little or no coding and no prior machine learning experience. Vertex AI can help you create your own chatbots, digital assistants, custom search engines, knowledge bases, training applications, and more. Lastly, there is Gemini, a multimodal AI model. Unlike traditional language models, it's not limited to understanding text alone. It can analyze images, understand a multimodal not digital, little or no coding, and no prior machine learning experience. Vertex AI can help you create your own chatbots, digital assistants, custom search engines, knowledge bases, training applications, and more. Lastly, there is Gemini, a multimodal AI model. Unlike traditional language models, it's not limited to understanding text alone. It can analyze images, understand the nuances of audio, and even interpret programming code. This allows Gemini to perform complex tasks that were previously impossible for AI. Due to its advanced architecture, Gemini is incredibly adaptable and scalable, making it suitable for diverse applications. Model Garden is continuously updated to include new models. And now you know absolutely everything about generative AI. Okay, maybe you don't know everything, but you definitely know the basics. Thank you for watching our course, and make sure to check out our other videos if you want to learn more about how you can use AI.
Okay, a lot to get stuck into there. A lot of terminology that I'd have to learn.